Hey, so today we're going to talk about one of my favorite math concepts, and that is imaginary numbers. So, for years, I have told you guys that you cannot square root a negative, right? If you square root a -1, for example, your calculator tells you it is not possible. Well, welcome to imaginary numbers. So if I wanted to find the square root of a -9, for example, there's a way of doing that, and that's by what we call in math an imaginary number. We take out the negative. Whoops. So, and we just take out the negative with a -1. And we say multiply that by the square root of 9. And now we can find it, right? It's going to be 3 times the square root of -1. But one thing that we do is we kind of treat that, or we have another name for that square root of -1, and that's just I, or imaginary number. So we could also write that as 3i. And we treat that kind of just like with any variable, but it has some additional properties, which I will get into. So the imaginary number, I, is always just equal to the square root of a -1. That is what I equals, right? But what if I took the square root of -1 and multiplied it by the square root of -1? Or in other words, I did I squared. Well, the square root would go away and it would just become -1, right? Yeah, it's not too bad. That's an actual number there now. It's no longer imaginary. It's a real number. Well, what if I cubed it? I to the third. So that's -1 square root of -1 times square root of -1 times square root of -1. Well, what ends up happening is you have -1 times square root of -1, or I, which would give you a -I. Okay, well, we're back to imaginary. But what if I did this? What if I did I to the fourth? Well, that would be 4 square roots of -1 multiplying with each other, which, when you do that, that would give me -1 times -1, right? Which is going to equal +1. So if you can get 4 imaginary numbers multiplying together, you get a +1. So basically there's a pattern that's going to happen. It goes from just one imaginary number, square root of -1, to -1 to -I to +1. And then if I were to add a fifth one, it would be back to just I, or the square root of -1, right? Because 1 times square root of -1 is just -1. So that's kind of a pattern to keep keep track of today. And that's kind of an introduction to imaginary numbers. Now, when we combine imaginary numbers with real numbers, we get what we call complex numbers. And they're not really that different than just equations, other than sometimes they might turn into actual numbers here. But today we're just going to be simplifying complex numbers. So that means we're just combining like terms, basically. So looking at number 1, for example. Number 1, I've got -2, 7, and -4 are like terms. So if I combine those, -2, 7, and -4, that'd be -6 and 7, so that'd be 1, and then -7i. Okay? That's as simple as I can get it. So that's my simplified complex number. Let's look at this next one, number 2. So this one, I've got a negative in front of a parentheses, so I got to distribute it, which changes the sign on both. So -3 plus I plus 5, and then -2i. Well, 5 and -3 combine to become 2. I and negative 2i would become negative I. And that would be your answer. And that's really all you're doing basically here. Next section gives me some i's to the powers. Remember, every fourth I is positive. So basically, if you want to figure out where it is on your spectrum, just take that number divided by 4. So if I take 42 divided by 4, that's 10.5. Or that would be 10 i's to the fourth and then 2 other i's. Okay, because I'm going by halves here. 2 other i's, so that would be my second I squared, which is negative 1. So that's just going to equal a negative 1. Again, if you think it like this, I to the 40th would be positive 1, and then you times it by I, times it by I. Times by I, you'd get the square root of negative 1, and times by I again, you get the negative 1. So that is your answer there. Okay, then for this next section, again, if I want to multiply these, I've got to take out the negatives. So this would be I square root of 15 times I square root of 25. So if I multiply those, I'm going to get a negative 1 times the square root of 15 times 25 is 375. And then I could have just taken out the 25 there. But I'm gonna take out the 25, and it'd be 5 times negative 1, which is negative 5, and then square root of 15. And that would be my answer. That's as simple as I can get it. Okay, I could have bypassed this step right here if I just took out the 5 and have 5i times that, and that would have worked too. Okay, let's do one more of those. Let's look at I guess I could do that. Okay, so let's look at this kind of monster problem here. So first of all, can I take out the 36? Yeah, but it's a negative, so I've got to take out an I. So I have I, and then it would be 6, right? 6i. Okay, then a to the third. I can't square root a to the third, but I can square root a to the second. So if I do that, I would bring out an a. And then b to the fourth, square root of that would be b to the second. And that would leave an a, and that's it. And my square root. And that's my simplified number right there. Again, the key there is I cannot take out that negative square root, so I have to pull it out as an I. And that's what you do with simplifying complex numbers.